Hello viewers, in today's class we are going to learn about the concept of second order derivative, right? So let y is equal to fx be a function, right? Now we know that the first derivative is dy over dx, right? The first derivative is dy over dx, or it is denoted by f dash x or f prime of x. Now if we differentiate the first derivative, right, if we differentiate the first derivative, then we get the second order derivative, right? The second order derivative, and the second order derivative, it is denoted by d2y over dx2 or f double prime of x, right? Similarly, the higher order derivatives can also be written here. Suppose if we want to find the third derivative, then the third derivative is denoted by d3y over dx3, or we can denote it by f. Here we have triple prime and it is denoted like this, right? Similarly, fourth order derivative, fifth order derivative, and the nth order derivative is denoted by dny over dxn, right? So this is the nth order derivative, or it can also be denoted by fn of x, right? So here we'll restrict ourselves to the second order derivative, right? So let us take some functions and let us try to find out the second derivative of the given functions. Now let us take this function, that is y is equal to tan inverse of x. Now here we want to find out the second derivative of this function. So what we will do, we'll first find out the first derivative, that is dy over dx. So dy over dx is the derivative of tan inverse x, and by the standard result we know that the derivative of tan inverse x is 1 over 1 plus x square, right? Now to find out the second derivative, now we'll differentiate this first derivative. So we can write d over dx of dy over dx, which can be written as d2y over dx2, right? So we'll differentiate this function, right? So this function is 1 over 1 plus x square, right? Now to differentiate this, we can write it like this: 1 plus x square raised to minus 1. Now here we'll apply the chain rule, right? So first we'll apply the rule d over dx of x raised to n is nx n minus 1. So we'll take 1 plus x square as 1 unit, that is x raised to minus 1. So this is minus 1 plus x square minus 1, and then we'll differentiate 1 plus x square, and the derivative is 2x. So this can be written as minus 1 plus x square raised to minus 2 times 2x, which can be written as minus 2x over 1 plus x square whole square, right? So this is the second derivative of y is equal to tan inverse x. Now let us take this polynomial function, and here we want to find out the second derivative. So let us first find the first derivative. So dy over dx is equal to this is x cube, so the derivative is 3x square, and then we have the derivative of x square as 2x, so this is 8x, and the derivative of x is 1, so we have minus 7, and the derivative of 3 is 0, being a constant function, right? So this is the first derivative. Now the second derivative is d2y over dx2, so the derivative of x square is 2x, so this is 6x, and the derivative of x is 1, so we have here only 8, right? And the derivative of 7 is 0, being a constant function. So the second derivative of this function is 6x plus 8. Now let us take this function. Now here we again will find the second derivative. So let us first find the first derivative. So here dy over dx is the derivative of log x is 1 over x, so this is 1 over 2x, and then by chain rule we'll differentiate this 2x, and the derivative is simply 2. The derivative of 2x is 2, plus here we have e raised to 3x, so the derivative of exponential function is the function itself, so this is e raised to 3x, and the derivative of this 3x is 3, right, by chain rule. Now dy over dx is equal to, here 2 and 2 get cancelled, so we have 1 over x plus 3 e raised to 3x. Now let us differentiate it once again in order to get the second derivative. So d2y over dx2 is the derivative of 1 over x is minus 1 over x square, and the derivative of e raised to 3x is e raised to 3x times 3, right? So this is minus 1 over x square plus 3 3s are 9, 9 times e raised to 3x. So this is the second order derivative of this function. Now let us take this function y is equal to log x divided by x, and we have to find the second derivative. So what we will do, we'll first find the first derivative. So dy over dx is equal to d by dx of log x over x. Now here we see that this function is the quotient of two functions, right? This is of the type f over g. So here we'll apply the quotient rule, and the quotient rule is g times df over dx minus f dg over dx divided by square of g, right? And here g is not equal to 0, right? So we'll apply this rule to this function. So here f is this is f and this is g, so we have x, then derivative of log x minus log x derivative of x, right, and divided by x square. Now this is x, derivative of log x is 1 over x minus here we have log x, then derivative of x is 1 divided by x square, right? Okay, now here dy over dx is now equal to, here x and x get cancelled, so we have 1 minus log x divided by x square. So this is the first derivative. Now we have to again differentiate it. So the second derivative is d square y over dx2, and we can write it like this, dy dx of 1 minus log x divided by x square. Now again, this is the quotient of two functions, and we'll again use this rule. So this rule, if we apply here, we have x square, then we have derivative of 1 minus log x, then we have minus 1 minus log x, and derivative of x square, right, and divided by x square whole square, right. Okay, so now we'll simplify this expression. So here we have x square, then the derivative of 1 is 0, the derivative of log x is 1 over x, so we have here minus 1 over x, minus here we have 1 minus log x, then the derivative of x square is 2x, right, and divided by x raised to 4. Okay, so now here x and x get cancelled, so we are left with minus x, then we have minus this is minus 2x, so we have minus 2x plus 2x log x, right, divided by x raised to 4. So we have minus 3x plus 2x log x divided by x raised to 4, and cancelling out 1x from the denominator, we have minus 3 plus 2 log x divided by x cube, right. So therefore we see that the second derivative, that is d2y over dx2, is equal to 2 log x minus 3 divided by x cube.